questions on the assignment from 10.1? Incidentally, I did find the two note sheets or the two pages from yesterday that were somehow missing off the note sheet because they somehow managed to make it on the front of this one. Because if you notice, the first two problems or the first two parts on this note sheet are the last two slides from yesterday. So I'll have to fix that. Because what we're starting off with this here is major and minor arcs. Major and minor arcs of a circle. Yeah, we're going to skip those first two. I'm going to move them over to 10.1 and get that fixed. If the measure of ABC, angle ABC is less than 180, then the points on circle C lie in the interior of angle ABC form a minor arc. So what that's saying is if the measure, let's get a pen. If the measure of this angle is less than 180, then the arc here from A to B is going to be a minor arc. Any arc that measures less than 180 degrees is going to be a minor arc. Any arc that has a measure greater than 180 degrees is going to be a major arc. And the way that we label arcs is with putting a little arc above it. So we can say AB with an arc, or here, ADB. And whenever we use two letters to name an arc, we're talking about the shortest distance between those 2 points. So if we say arc AB, we're going to go from A to B, this direction. We're not going to be talking about the direction going this way here. Whenever we have two letters, we're going the shortest distance from those 2 points on the arc. Now to get the major arc, yes? Because we're starting at A, going through D, and finishing at B. Because the first and last letters of the 3 or 2 is going to be the start and finish. So AB says I'm starting at A and I'm finishing at B. And since there's only 2, I'm going the shortest distance. Now, for major arcs, when we use 3 letters, what this is saying is I'm starting at A, going to go through D and finish at B. So just kind of like with angles, how we traced it out, arcs are the same thing. First letter is where I start, last letter is where I end. And a semicircle is an arc with endpoints that are the endpoints of the diameter. So if we have a diameter, the arc that connects it along the circle is going to be a semicircle because it's half the circle. The measure of a minor arc is the measure of the central angle. So if we have an angle whose vertex is the center, whatever the degree of that angle is the same as the degree of the arc. So since the central angle here is 50 degrees, it means this arc is 50 degrees. So from A to B is 50 degrees. Well, we know what a circle is. A circle is how many degrees? So what we can do is subtract that from 360 and get that this other arc is 310 degrees. And whenever we talk about the measure, we put that little m in front of it to say this is the measure of arc AB. Any questions on this here? Find the measure of each arc on circle P, where RT is the diameter. So RS. So from R to S, well, we're told that its central angle is 110, yes? So that means the measure of arc RS is 110 degrees. And again, since it only gave us 2 letters, we're going the shortest distance from R to S. Let's look at the next one. So the next one is RTS. So we're starting at R. We're going through T, and we're getting to S, yes? Yes. How did we get to 250? Right, because we know that RS is 110, yes? So RTS is the other side, so we can take 360 and subtract 110 from it, which would give us 250 degrees. Let's look at the last one. R through S to T. What would this one be? It would be 180. Because RT, the line segment RT is the diameter. The diameter is what? 180. It's half the circle, yes? Because we cut the circle in half. So RST has to be 180 degrees. Anytime we connect an arc to the diameter, it's going to be 180. Any questions on this here?
So that means for ST,
Yes, ST would be 70 because those two have to add together to be 180. So we're told that AB is the diameter, and we want to find the length of AD, BAD, and DBA. So AD would be DAB, DAB. Well, this one's a little different, isn't it? Because this time, unlike the last one, where it actually didn't include the 65, that angle given to us, this time it does. So we can't just say 360 minus 65. We can, because this side over here is 180, yes? So we can do 180 plus 65. Yes. And the last one is B, so BDA, which is 180, because it makes up half the circle. Any other questions on these here? Okay. First big property that we've covered, because, I mean, we covered some so far, but our first big postulate of the chapter. The measure of an arc formed by two adjacent arcs is the sum of those arcs. Anybody's mind blown yet? So if this one is, let's say 90, and this one's 80, we can add their measures together. That's all it's saying. This is the same as our angle addition property, because if I have two angles next to each other, we can add their measures together. That's all this is saying. The measure of an arc formed by two adjacent arcs is the sum of their two arcs. We can add them together. And really, we already did that, because in the last one, we added 180 and 65 together to find it. Here, so we can look at GE first, which would be what? 40 plus, and 40 plus 80 is what? So GE is 120 degrees. What's the next one? G, E, F. So how can we get to it? We could do 40 plus 80 plus 110, yes? Do I already know what 40 and 180 is? 120, we already found that. So we can just do 120 plus, which gives us 230. I don't know why I wanted to do 3, because that's way too big. 230 degrees. And the next one, GF. So would I go from the right? Would I go this way? Left. Because again, since it only gave us 2 letters, we're going the shortest distance from one to the other. Right, since we know that GF HF or GEF, either one, is 230. We know the whole circle is 360 degrees. We can subtract them, which gives us 130 degrees. Any questions on this here? All right, we'll look at one more dealing with this here, and then we'll move on to the next part. So when we look at this here, it's the same thing we just did. A recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measure. So AC. So which two are we including for AC? The inventor and musician, because again, only two letters, so we're going the shortest distance. So we would be adding 108 and 29. So the measure of AD is 137 degrees. Let's look at the next one, ACD. So A, 2C, and finish up with D. So exactly, inventor, musician, and athlete. Well, we know inventor and musician add together to be. And we can add to it 83. Yes, it'd be 220 degrees. ADC, so we're starting at A, going through and finishing at C. Actor, other, and athlete. So 79, 61, and 83. And we can add these three together. So we get 3, 8, and 8 is 16, 223 is the measure of ADC. And lastly, we have E. Everything except for what? Other. So how can we get to this? Yes. I mean, there's different ways we can get to it. Because ADC kind of covered that way. ACD did cover everything except for actor. So we could have used the 220 and added 79 to it. Because 299 would be it, yes. So there's different ways we can go about adding these together to get to the answer. Questions on this here? We're not going to worry about that one then. Okay, identify the given arcs as major, minor, or semicircle. TQ. Why? There are two letters, but what's the measure? 120. A major arc is what? Greater than 180. A semicircle is? Well, semicircle. Semicircles. Half, so it's 180, yes? Minor arc is less than 180. So QRT, it would be major. Because do we need to know what SR is? No, because we're going from, get a different color, Q to R to T, yes? Well, it looks like TR is half the circle, yes? Is half the circle included in this one? Yeah, so this here is a major arc. And lastly, TQR. Is it possible for an arc to be a semicircle and a minor arc? Because by definition, what is a minor arc? Minor arc is what? Less than 180. And what's a semicircle? So can an arc be less than 180 and 180 at the same time? No. So could it be major and a semicircle? Well, no, because major has to be what? Bigger than 180. So none of these arcs could be more than one of these. They have to be minor, major, or semicircle. They got to be one of those three. QS. So let's see what RS is, because again, 60 and 120 tells us that RT is 180, yes? So that means the line segment RT is half the circle, it's the diameter. Which means that this one, okay, would have to be 100. So QS, from Q to S, is 160. So that would be minor. Arc. How about TS? Would be minor arc, yes. RST, semicircle. Now, just because it does have three letters doesn't guarantee it to be a semicircle or a major arc. Because QRS would be the same as QS, yes? Three letters, it's a minor arc. So it is possible for three letters to be a minor arc. But it's not going to be possible for two letters to be a major, because again, we're always going the shortest distance. Congruent circle theorem. Ready? Two circles are congruent if and only if they have the same radius. If they have the same distance from the center of the circle, then they have to be the same. Because how did we define a circle? A circle is the set of all points on a plane that are equidistant from a center. So if they have the same radius, well, they have to be the same. In a circle, in the same circle, or in two congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So if we have two congruent circles, or in the same circle, well, if these two angles are congruent, these have to be congruent. Because if this is 60 degrees, well, we know that this arc has to be. And if this is 60 degrees, we know that this one has to be. So therefore, the two arcs have to be the same. Now, the deal with this is they have to be congruent or in the same circle. Because when we talked about angles, especially in triangles, if I made the triangle bigger, side length's bigger, but didn't mess with the angles, it's still 60 degrees, yes? So this here, if I made the circle bigger with the same angle setup, that'd still be 60 degrees, no matter if it is this size or that size. It's still going to be 60 degrees. So that's why they're saying the circles have to be congruent, because we're talking about a degree measure, not an actual length. All right? Because when we start talking about length, we're going to have to switch over to radians. Radians, when we start talking with pi, we're actually talking about the length of the circle, not its degree measure, the amount of rotation. tell whether the two arcs, red arcs, are congruent? Yes. They have congruent. What would we call them? Not just angles. Central angles. Because the angles whose vertex is in the center of the circle are central angles. Questions on this one here? So are these two red arcs congruent? Because they're both 90 degrees, yes? Are the two circles congruent? No, one of them is bigger than the other. Yes, because they're inside of each other? No. The circles aren't congruent. Because again, when we say congruent, it means they are the same, the exact same. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So here, TU and SR are actually 90 degrees, but they're not congruent. Their actual lengths are not the same. So here we know the circles are congruent because their radiuses are the same. Yes. Because the two circles are what? And so are their central angles. Because their central angles are congruent and the circles are congruent, it means those arcs have to be congruent. That's it. Questions on this here? We like this so far? No. No. Not congruent. So PS is 180 because it's straight line. So we can add 65 and 50. $115 and subtract that from, which gives us, so yes. Yes, congruent. Questions on this here? Are you ready for the last theorem of the day? Similar circles theorem. Okay. We ready for this? All circles are similar. Because what are we changing to make a circle? To make a circle, we're putting a point and a radius, yes? Because that's all a circle is. And then we kind of draw it around to make the circle. So the only real dimension that we're giving to a circle is the radius, and it's a set of all points wrapping that around. So really all circles are just, we're making them either bigger or, so they are all going to be similar. They're all similar to each other. That's it.